today's class, we would like to progress regarding the continuation of this NDT applications, which plays a major role in the case of this industrial sector. Reviewing towards the yesterday's class once, as per the industrial processes has been considered, this non-destructive methods plays a major role that the inspection will be progressed without having any direct contact with respect to the working material. And under that, we will review the studies class related to the dye penetrant testing process, sonic testing process, ultrasonic testing process, magnetic particle testing process, radiographic testing process, ND current testing process. We'll be having a glance regarding first 3 to 4 different application processes. First 3 different application processes as this dye penetrant testing process, sonic testing process, and ultrasonic testing process. We have a detailed discussion in the yesterday's class that we will be just polishing out once and proceeding towards the next 3 different methods which is utilized in the industrial sector for different inspectional process. What is the type of inspection? What are the analysis that has been done under the application process? And what is the process of the application? What are the advantages regarding this? Disadvantages regarding the each and every type of application process we will be discussing in detail. So plainly we will be proceeding with respect to the starting 3 which we have been discussed in the yesterday's class, and detailedly we will be discussing in the 4, 5, 6 concepts. Coming to the dye penetrant test or liquid penetrant test, it is a technology which is widely utilized in the industrial sector for identifying the invisible cracks, particularly in the case of this visual inspection technology. Even indeed to find out the porosity of the objects, and most probably almost all the components and almost all the materials which are available globally can be have a detailed conversing regarding it for the identification. And for this, the procedure related towards that is having 6 different types of steps. First one, pre-cleaning is required, and after completing the complete process, post-cleaning is required. Coming to the pre-cleaning process, initially with respect to the pressurized water that need to be cleared because it should be dust free. Because the object which need to be measured should be dust free. So here, initially, before cleaning, the object upon measuring will be like this. So after cleaning, the dust which is deposited at the crack levels will be getting defeated. Later on, application of the penetrant. And next, intermediate cleaning, nothing but additional penetrant which is deposited on the layer that will be getting decreased or eliminated. And later on, applying the developer. So developer safeguards the identification of the cracks and glance the crack that has been identified here. Coming to the crack indications, this developer helps us to exclude or overlook the crack which has been identified upon the inspection process. So later on, after finishing out of this crack indication, the post cleaning is required. Post cleaning in the sense almost after the completion of the elevation process, not the completion of the elevation process. And these are the pictorial representations of the objects to be measured, and these are the penetrants and the developers that have been applied during the application process and to examine minimal cracks, particularly the minimal cracks which are being existing for clear-cut visualizations. Coming to the advantages, so only the surface levels and the subsurface levels having confided related to this liquid penetrant test or the dye penetrant inspection method. Basically, regarding this, a skillful worker is necessary indeed to operate these conditions, because if at all the acidic solutions or else the basic solutions, there is no any problem. And even that, upon reaction with respect to the environmental conditions, will leads to some of the hazardous situations. So based upon that, the safety precautions such as gloves or else the aprons, shoes are required for complete closing of the body with respect to the different ornaments. For safety devices is required in the operational process. So as one sector, next, the results which are being interpreted very much fastly upon the testing process. There is a greater advantage in the case of this differential testing process. And when compared to the other testing process, such as this magnetic testing process and the ultrasonic testing process, high sensitivity will be getting achieved regarding this testing process, and that too, there is a limit to some extent. There is only the surface finishing and the subsurface finishing up to a particular depth constraints as being required. And second thing it is, if pre-cleaning is the additional factor and post-cleaning is the additional factor that is to be done for inspection process. And here, direct contact is not at all up here, but a liquid which will be deposited at the particular cracks plays a very important role for identification of the cracks. And the greater disadvantage here it is, in the case of powder metallurgical components, the testing performance cannot be acetated or cannot be entertained. That's the disadvantage that we get here. Coming to the ultrasonic test inspection, we all know that 20 to 20 megahertz of frequency percent nominal utilization or capability of hearing in the environmental sector. So beyond the 20 megahertz of frequency has been utilized, then automatically it is called ultrasound. Nothing but echo effects which are having a greater frequency than the visual factors, those will be coming under the ultrasonic testing inspection. So the sound is being created or echo effects that has been created externally. And detailedly we have discussed regarding this in the test class. And the limiting of the sounds or echo effects will be confined to the cast iron materials, cups, saucers, earthen pots, coconuts, etc. This will be absorbent and enclosed sound finishings. Sound limits, we can say, or non-generative of the echo factors, non-passage or non-conductivity of the echoes within the materials. And even if the external pressurized conditions also, in the external pressurized conditions also, it limits to a maximum extent. So basic principle is these echo effects which has been generated externally will be impregnated through the probe in a particular spaces or in particular area of the workpiece. There is three-dimensional objects, but we are having one benefit rather than compared to the liquid penetrant testing process. So what we have learned till now, that is in the case of this liquid penetrant testing process, the liquid or penetrant will be formed that will be applied on the surface, only the surface level cracks up to a particular thickness of cracks, up to a 2 mm of thickness or 3 mm of thickness. Basically, those are the only cracks can be identified in the case of this liquid penetrant testing process. But in the case of this ultrasonic testing process, there is a great advantage we can say when compared to that particular process. Here, the echoes which are generating very much at a high range of frequency, more than 20 kilohertz of frequency, and to the maximum of 20 megahertz and greater than 20 megahertz of frequency will be utilized for identifying the maximum thickness containing of objects. So where the object which need to be measured will be placed within the Jackson fixtures and limits to it of unfolding and implementing the penetration of this echo effects which has been generated externally through the material, passing through it and identifying the behavior of the waves, whether they are penetrating through the material or not. This is a clear-cut example. It's the thickness And in the case of this liquid penetrant test, we will be having only the surface level defects and up to particular thickness, that is 3 mm or 2 mm, like that. And for example, we are considering entire this object will be having of 20 centimeters or 30 centimeters. Commonly, we will be considering. So this is the probe which will be having producing the sound waves only to a particular surface area. Up to this surface area, only the echo waves will be produced. And this is the device which is having the capacity of transceiver capacity. Basically, in the case of this ultrasonic testing process, we are having two different types of factors. Transmitting device will be from one side and receiving will be from the other side. That is one type of inspecting technique. And the initial technique is the transmitter itself acts as a receiver also. Hence, we can say that it's a trans receiver. So, hence, this plays a major role indeed to identify the heavy depth considering of the objects. Greater advantage. So, this is the principle of inspecting in the case of ultrasonic testing process as a particular area where the probe is being occupied the space over the work plan. That will generate the waves to a maximum extent and up to the end surface of the object, and hence the return back of waves will be getting identified. So the traveling distance of the waves will be captured in the CRT scale, if at all, and overall depth of the material also will be specified in the default conditions. Nothing but the overall dimensions of the material will be specified to the comparator. So hence, how much depth? So to the given input depth, whether almost all the distance as per the input conditions has been traveled by the generated echo or not will be clearly verified. If at all, a defect has been identified here as displayed in the diagram. So at a what distance from the surface level of to which depth the sound wave has been passed and the reflector has been collected. So the traveling distance will be plays a major role here. And we are almost having the default conditions that at the input range, the overall depth of the object has been specified. So this is the depth that is not at all traveling by this echo or sound wave. Hence, this is the difference in the comparator it will be identified with respect to the input conditions given manually. So manually in the sense, the dimensions of the object which we have been given as an input to the system. So it will compare to which distance, to how much distance that particular echo effect has been traveled and return back to the receiver or trans receiver again. So that distance plays a major important role, and based upon that calculations will be having a detailed measuring device. This is the length that will be generated by the echo or traveling by the echo. That will be clearly identified. The second way of methodology, as we have been discussed, that generating or triggering of the echo effect will be from one side, and next a receiver will be one side. So here transducer is a concept. So what's meant by a transducer? It's an electronic device which have the capability of transforming the signals or energy from one form to the another form. Particularly, you can say that's from one form to the another form. Hence, in the physical form, we are being generating the sound wave, and next receiving the same physical form of the sound wave and transforming this to the electrical pulse, nothing but in the form of voltage or current. That will be conducted to an electrical circuit and will be measuring that electrical voltage which has been identified in the form of conversions at the conversion state by this transducer basically. And next, the converter plays a major role, that is A to D conductor or DTA conductor, and displays in the display screen with respect to an pictorial representation or digital wavefront format, having that in the analog display format, or else in the directly if this analog to digital converter has been placed in the electrical circuit, it will be displaying with the numerical characteristics such as 21.1 or 21.2, like this. In a digital representation, 7-segmental display representation. That is a greater advantage that we'll be considering in the case of our greater advantage. It's coming to the basic advantages related to this ultrasonic testing process. The internal level of the flaws also will be identified in this ultrasonic testing process. And we are having a better enclosed finishing that leads to a high sensitivity for generating the values. So for inspection process, high sensitivity, the high sensitivity, the values will be getting generated. Nothing but we can call it's a reliability values that will be equivalent to the standard values. And even the equipment is portable, very much easy to handle. Coming to the output of the test, it leads to a result reliability. So clearly this point specifies for it. This point specifies that the testing results will be generating in a high valid ratio, in a high valid ratio. When considered the limitations point of view related to the ultrasonic testing process, because that sonometer normally we will be saying one of the devices which is used to generate the electrical pulses or echo effects. In the engineering physics, you will be doing that experiment also in the case of this physics subject in the laboratory. You might have done also. So, due to the manual operation of that particular sonometer, which is having the best capability of generating the sound waves idealized, and those will be captured and traveled from the external medium with respect to this transceiver, and next it will be penetrating into the material. So the operation of those transceiver and transforming or setting in connectivity of those sound waves or echo effects generated should be handled very much carefully, because it's a manual way of operation of generating of the echo effects. And further, a skillful worker in the sense almost an expert in that particular area is required for operating that process. And another one more defect is irregular shape of objects cannot be identified. And subsurface discontinuous are very much difficult to identify its entire basic structure, even to its surface finishing also. That's one of the defects in consideration of this ultrasonic testing process. Even for an enlargement of inspection, components are required for increasing the frequency of the sound waves. So far, there's a brief glance regarding this liquid penetrant testing process, sonic testing process, which will be utilizing for less frequency or medium frequency of sound echo effects and identifying the effects of the object, and at a greater frequency, nothing but if the thickness of the objects has been increasing, and entire the examination process has to be performed in the sense the frequency should be increased rather than the normal utilization of the frequency, that is about 20 megahertz of the frequency. Hence, it's a greater advantage for us indeed to identify the internal cracks also very much clearly, and to which depth it is being existing, and to which dimensional areas the crack has been produced, and what's the chemical composition effects or mechanical properties at that particular zone of crack, whether those are having the capability of removing or not by filling the material at that particular place. So crack has been identified in the sense there is no any part of the material getting the deviating of the material only at that particular place. That's due to the external offense that has been placed between the layer. That's the first point need to be observed, and later on In the casting process, during the casting process, if there is any air bubblers or voids has been created. So that's also will be related to second considerations. So those will be clearly observed and up to which depth it will be existing will be identified very much clearly in the ultrasound testing process. So removing of the internal stresses, normally we could say that those are the internal cracks or internal defects normally. You can say internal defects. Those will be getting removed by this our heat treatment processes. So heat treatment processes in the sense our annealing process, normalizing process, nitrating process, carburizing processes, which we have been learned in our MMS subject, such that our entire component will be taken to the austenite range of temperature. And austenite range of temperature in the sense almost even the ferrous content of material or non-ferrous content of material, so ceramics or water must to which that particular temperature need to be maintained, where semi-liquid or semi-solid state of that particular material need to be taken. And later on that, the internal stresses will be getting removed, but filling of the gaps will be confined at that particular area. And hence, slow process of cooling leads to the solidification process. Automatically, the defects will be getting relieved towards the surface. So at the surface, we can do our machining operational process for getting the finishes, good finishes, through the high surface finishes. Coming to this magnetic particle testing process. This is also the testing process utilized in almost all the industries where the welding defects can be identified, casting defects can be identified. So far, we have been discussed that casting defects and even the forging defects, different forging defects, but repeatedly application due to the repeated application of the loadings in order to transform the material plastically to the required shapes coming under the forging conditions. And these may be the conditions that will be happening most probably in the ferrous content of materials, particularly in the iron composite materials and the steels. And upon repeated application of those, the material leads to an internal stresses and that will deviate the structural deformations. So it may transform from one lattice structure to another lattice structure. As we have been discussed, the 14 different Bravis lattice structures may transform upon the repeated type of loading, which will be saying that a creep type of loading will be getting accessed in order to transform the entire material to our required dimensions. That to at a plasticity of range. In the case of this magnetic testing, particle testing process, they are having different kinds of methods. There's a wet method, there's one technology, and dry method, there's one technology. In the case of this dry method, fine ferromagnetic powder is applied over the surface of the object, which is need to be processed under the inspection. Particularly, it's the testing process will be confided towards the manufacturing of aerospace components and different types of automobile parts which will be utilized within the industrial sector. And by this, the magnetization will be getting done with respect to the materials for identification of the internal cracks existing. During the casting process, we need to get the definite shape of the objects or parts in the manufacturing area. So during the casting process, shrinkage cavities will be getting opened, hot tears will be getting taken place in the solidification process while the solidification process is being commenced. And zones of corrosion at that particular range, corrosion, when it is getting reacted, the material is getting reacted with respect to the normal atmospheric conditions. There is an oxidation process, late state corrosion. Ferrous kind of materials, when it has been reacted with respect to the oxidation process, then the zones of corrosion and non-metallic inclusions. Coming to the Magnaflux testing process, it's also related towards the dry testing process in the course of this magnetic scenario. So cleaning of the object which is need to be tested is compulsory. And magnetizing the object so that the magnetic properties such as the polarities will be infused within the material and it will be getting better for the inspection technique. Later on, application of this ferromagnetic powder over the surface of the material is need to be observed, and later on this observation or experimental process should be getting done. And after the completion of this inspection process, demagnetizing of an object will be getting done. That normal environmental conditions will be achieved back to the object again. This is nothing but the Magnaflux inspection method. So upon inducing of the magnetic properties, the polarities will be obtained towards the material. Based upon that, the magnetic flux will be getting induced over this material in a particular direction from north pole to south pole, north pole to south pole. The particle movement, and that creates the field of energizing in between the material. And later on, the electrical effect, depending upon the coil, will be ruled over that particular material, which need to be identified. As per our Lenz law concept has been considered within the magnetic coil or core, the AC power supply will be introduced, and so that the secondary winding, the flux will be getting generated, and the field will be getting varied at that particular crack areas. For example, see here in the vectorial representation, this is the cast iron rod need to be processed by the case of this magnetization testing process. So in the casting process, it will be having different deviations. So internally, we are having the cracks, and even at the surface finishing or underneath to the subsurface finishing level. So we may have the problems in the case of this casting, or else due to the overloading. Some of the defects or deformations will be getting confirmed. So when the electricity has been passed over there, the circular orientation of this electrical capability will be taking place, and the magnetic field will be getting generated from the one pole to the other pole, this from north pole to the south pole commonly. And where the crack has been identified, the flux deviation will be getting taken place. But the orientation or the circular electrical pulse will be getting deviated in its direction. So it's the circular impregnations or flowing of an electrical capability or generation of this magnetic field upon the magnetization element. And where the point of this particular defect has been identified, here the deviations or deformation of its zone or field will be getting taken place. So circular will be changed to the deflection in its direction. It may be in a concave direction at that particular, only at that particular area, concave in nature or the convex in nature. Due to the type of the defect, it will be having in different, varying its field generation in different directions. And the deviation, based upon the deviation, to which level or to which dimension that particular crack has been identified, or else the air voids are being identified during the casting process, or else the overload or due to the externally applied load, whether it has been confided or not. That will be having a clear cut identification. So by the use of this iron powder will get very much clear in the case of Coming to the advantages of this magnetic flux, the internal subsurfaces are also can be easily detected, and almost any kind of the structural oriented and different sized and different shape of the components can be clearly identified in the case of this magnetic testing process. And almost in the case of this magnetic testing process, the instruments are very much portable and are very much easy to handle, and no any skillful actions or working constitutions are necessary. Most probably, these are very much sensitive method. It's a very much sensitive method which generates the minute or small and shallow surface lines. Coming to the disadvantages related to the magnetic flux, this method is suitable for identifying the defects in the objects related to the ferromagnetic materials, mostly related to the ferromagnetic materials. And if at all any of the polymer coatings has been existing over the materials, normally it will be a bit difficult for the identification. The light defect that in a particular range, which cannot be having the conformity for its identification. Local heating and sparkling is possible during the test, and hence proper care should be taken for commencing of this process. Coming to this radiographic technology, as we have been discussed very much in detail, very much detailedly in the case of our unit number 1, that with the help of this X-rays or else the gamma rays, by projecting with respect to the radiations over the materials and identifying the defects existing internally within the materials. And even it is compatible with respect to the magnetic testing process or else the echo testing process that we have been just visualized the ultrasonic testing process. Most probably in the case of this radiography technology, we are having X-rays, Y-rays, gamma rays, ultraviolet radiations, etc. But most probably without affecting the manual kind or human kind, this X-rays and gamma rays plays a major role for identifying this discontinuities in the materials. And up to what range of discontinuities or defects or cracks that has been identified, that will be capturing in the form of these images, or that images will be getting recorded. And in some of the cases, indeed, to identify the casting defects or welding defects, this radioisotopes technology are also preferred, which is one of the radiographic technology in order to identify the following defects. Coming to the procedure related to it, the particular rays regarding the X-ray finishing or else this gamma ray finishing or radioisotopes will be getting projected towards the material by by the generation of these rays, radiations. A fluorescent screen will be displayed over it, and an commutator will be getting placed in between, and the source point will generate the light rays and that need to fall over the object very much clearly, to which the surface need to be examined, and hence this rays projects towards the materials and to a maximum depth constants. So toward the material, the rays will be getting projected and will pass through the medium and get the clear-cut pictorial representations in the films. For example, it plays a major role in the medical agitations also. Normally, before that, if any of the cracks has been identified in our bones, X-rays plays a clear-cut role to which level it has been fractured, how much the deviations has been compared, to how much centimeters or mm's of the to which that continuity has been taken place. So this is the source of this rays generation. It may be from the X-rays or the gamma rays. It may to produce over the project over the material. Is the material need to be identified, and the internal aspects will be clearly examined, and here the film will be getting placed out. And that will be captured in the particular film. That's normally in the medical point of view, we'll be getting that film. And this is the clear-cut analysis. So this is the surface defect for our instance, and this is the internal crack or voids or holes that has been identified, and to which range, to which length it has been identified, that will be captured over the films. And this is the internal parts or generation of this X-rays utilized by the cathode representation, which has been utilized by frequent high voltage electrical power supply that will be amplified to 240 volts of power supply, and even incrementing in its three-phase accessibility also. And range of the area can be identified because of its opaque nature, because of the opaque nature of the rays. To the maximum area of analysis, and even it is a range, if at all, the distance of the range or photon speed has been increased, automatically it is having the greater capacity for identifying the internal deflections of the object. Its strength will be getting increased. Coming to the advantage point of view, in the use of this radiographic testing process, it's very much sensitive and rapid process. Within a fraction of seconds, it will be getting captured. Even we use it to visualize in the hospitals also. Within a 2 to 3 seconds, entire the projections will be getting passed away, and the display will be getting captured over the films. Even in the gamma radiations also, high power penetrating rays captured in the form of the pictorial representations. In the case of this digitalization process, those pictorial representations will be getting saved in a file of code. Coming to the disadvantages related to the radiographic technology, these extra radius are being applied only for thin components because it is having a less penetrating 3.45 meters per initiations. And particularly, it is allowing only one component to be tested, because if the another component has been placed already, the thickness of the material will be increasing, and it does not have the range of its penetration to the other material. And regarding the economical point of view, the initial equipment setup is very much high in cost, high cost oriented. And these radiographic technique methods, X-rays and gamma methods, these are very much hazardous when it leads to skin rashes or some of the skin defects, skin problems. Only the trained or skillful persons are required to operate over this machineries, and that too in an enclosed areas. That too in only the enclosed areas. So these are the defects related to the radiographic technology. Coming to the anti-current testing process, which is also one of the testing process, plays a major role in the industrial sector, where The principle of this eddy current testing process is nothing but when a coil is carrying an alternate current which is brought near to the metallic specimen which need to be identified, some eddy currents will be getting produced. That is nothing but the internal additional currents will be getting flown over that particular material. It's induly developed there. That too related to the electromagnetic effect. The induced EMF that has been produced based on the input current provided to the material. This eddy currents will be getting produced at the crack confined areas. Crack confined areas. Nominally, that deviates its flux in the range of its flux direction. So wherever the crack has been identified, nominally the flux direction will be getting changed, because wherever the crack has been identified, at that particular point, the polarities will be getting different. Nominally, we use it to see for a component north pole and south pole. If the crack has been taken place there, automatically polarities will be getting different at that particular point or crack areas. So at that particular crack area, north pole to south pole, it will be becoming, and another one more side, it will be becoming towards the north pole. So two will be a similar constraints. Hence, at the crack area, similar properties will be getting taken place towards the electromagnetic effect. So we all know that the electromagnetic concept, or else the magnetic concept, simply like poles will repel each other. So similar poles automatically repel each other. Due to the repelling conditions, this magnetic field will be getting changed in its direction. So that is the deviation in its magnetic field. And particularly in the case of this electromagnetic field, the AC power supply will be getting passed, and due to the passage of this input currents, eddy currents will be getting produced only at that defect areas due to the variation of its magnetic fields. So in that particular area, the magnetic field diversion will be getting taken place. That made very much easy for us to examine the currents. That's the basic concept in the case of this eddy current testing process. See here, clearly specified that magnitude of induced EMI depends upon magnitude and frequency of the alternating current which is flowing within the coil, just as we discussed. And the second point here is electrical conductivity towards the specimen, magnetic permeability of the specimen, and shape of the specimens. They should be very much clear and should have obeyed the magnetic properties towards it. And the relative positions of coil and specimen is confided. Internal microstructures and hardness of the specimen should be very much matched up with respect to the magnetic properties. We need to induce the magnetization concept towards the materials. So that's why we have been a clear-cut vision that only the ferromagnetic substances have the better accessibility in the case of this testing process. So iron composition of materials, simply you can say. And even amount and type of the defects in the specimen should be related to the quantity and internal defects, types of defects. So it's the equipment, the producing of the eddy currents. Here is the coil which is giving connecting the internal accessibility of the probe. The probe will be made to move or pass throughout the material. So wherever the crack has been identified, the field will be variated. So field generations. See, this is the difference. And the direction of field will be getting deviated. See, this is circular interpolation. Remaining area is all similar. And where the defect has been existing, the deviations in its concave structures. Concave structures. So hence we can identify the defect at the particular point. So here the surface finishing is not good. Hence this bulging situation has been identified. So it is not in finishing, surface finishing, good finishing. Having non-uneven structures. And this is the flaws identification. And See, this is the magnetic field generating in a circular mode, and wherever the crack has been identified, it is deviating in its direction of a magnitude. That's what we have been discussed. The flux deviation in its direction will be taking place at the identified fracture or flaw. Flaw is nothing but occurrence, minimal occurrence. And a crack nth distance from the other clearly will be identified. Right? This is the electro concept. And coming to the advantage point of this is a quick and less time consuming process. Similarly, with respect to the radiography texting process, within no time, a simple in a fraction of seconds, this process can be generated or having the capability of identifying the defects. When the probe has been in contact with a certain area, automatically it will be accepting or identifying the defects. And it's an automated testing process which is very much easy. And the permanent record of test results, which made very much easy. And it's an versatile and commonly utilized in various applications in the industry. Coming to the limitations of this process, the unit cost or instrument cost is very much high in economical point of view. And the maximum equipment which is having the highest thickness cannot be identified in the case of this testing methodology, ethical testing process. See here in this microstructure, hardness also can be identified, but with a limited conspiracy. So minimal thicknesses. So much not a maximum thickness. So just specimen thickness will be a limited level. So those are the disadvantages. And calibration is very much easy, and standard calibration should be utilized. So these are the processes, different kinds of processes utilized for identifying the defects within the object in the industrial sector. Thank you. With this, we have completed our sixth unit also, and entire year syllabus. I think it has been full-fledged concluded. And furthermost, I'll be halting for the final years, and I will be proceeding towards the